Okay, I've got 4 of these drives, elevator drives. 2 are bad and 2 are good. This is one of the bad ones. It's a little baby drive. They're pretty much throwaway. They don't do any component replacement on them whatsoever. They go bad, they just pull them out, throw another one in. That's why they were readily available, and I met somebody who just gave me a few that were going to go to the dumpster. So we'll take it apart, see what's inside, and try to figure out what's going wrong with them. We'll compare the good and the bad ones. See what's up. This actually came out of another failed elevator drive by the same company, but obviously it's a slightly larger version. This one is a 16L. I think that one might have come out of a 25. I don't know. But you can see these little baby capacitors aren't even meant to be changed. I guess that's why it's a throwaway drive. But I'm sure there's some cool stuff in there to scavenge. I guess that's where they changed the software. What's weird about this drive is where do the wires land? This is crazy. I guess under here. Let's pull that off and see what's... I assume maybe the power wires out of there. I don't know. You'd think there'd be a plastic bushing. Aha. T1, T2, T3. Okay, so you could probably test your freewheel diodes here and here. Probably do a few tests right here, but we'd really have to get it apart. We don't have any schematics on it. And the elevator companies, they actually don't break this stuff down for you because they're getting to the point they don't want you to get inside them and do any component replacement anyway. So we'll just have to take it apart and figure it out. All right, we're starting to get somewhere. All right, now we're getting to the meat of it. Yeah, I would say none of this is really meant for servicing. Here, hold on. Let's pull these off before we break that. Look at how loose that. Oh, you might have done that earlier. Let's see. Does that come off? Yeah. Okay. So if you have an auxiliary go bad here, they don't really want you opening this up to replace it. I guess this is like a 5-year drive. Change it out every 5 years. Wow, that's amazing. So I don't know what the common failure is. I have been told that there is some relay that commonly goes bad, but these little tiny drives, I guess the OEM gets them so cheap that they keep them on the shelf, and it's just with the labor cost and everything, it's just easier to replace the whole thing. With the bigger version drive, maybe they do component replacements. I'm not sure. I'd like to get my hand on a few more of the bigger ones though. Pretty cool. That is interesting right there. Wow. I just cannot believe this runs an elevator. That's difficult to believe when some of the elevators I work on have 36 of these. And this is what we've got here. Okay, so it looks like the UVW terminal go through this board mounted relay before they come over here to the IGBT interface board and whatnot, capacitor board. It doesn't really look like we could do any tests from here because that has to be made up. So right now, if we go V is brown, so we're on brown. We're going to come over to V right here. Make that relay up, Ryan, and let's see what happens. Yeah, so that relay has to be made up. Doesn't look like you can do a lot of troubleshooting on this when it's assembled. I guess that's why it's a throwaway drive. Just from one end, so say that end. Okay, here is where it gets a little tricky. That IGBT is attached to the heatsink. There's a cutout in the steel plate, but I'm sure it's soldered onto here. So it looks like we would have to remove it from the heatsink and then pull this whole board out. I was hoping to keep it attached to the heatsink, but that's not going to happen. Alright, I guess pull the board off, and once all the screws are out, we'll take the IGBT with it. This is probably a little temperature sensor there, so you'll have to unscrew that as well. Let's see, what's it labeled? R1, huh? Oh, you gotta cut those. All right, there it is. So we will have to unsolder this. That's going to be a lot of work. Probably more work than I'm interested in. I'll tell you what, why don't you run upstairs and download the data sheet for that IGBT. While you're at it, just get the data sheet for those caps too. Okay, so we have some data sheets. Here's the one for the capacitor. And you can see here we have the ESR. We can go ahead and check that with our new LCR meter. We may unsolder all those caps to do that. But what I'm most interested in is the IGBT right now. So we have that data sheet. And if we look right here. Alright, so looking at the data sheet, what we need to do is find out how each one of these numbers correlates to up here. The way we're going to do that, we're just going to unsolder everything, pull this off, and then physically read the IGBT, and then we can come back and come up with a basically a pinout number each one of these. So you can see here UVW should go UVW. See the gate, emitter, whatnot. I would like to know how to check all that right here, but having said that, this isn't meant to open apart and test any of that, really, to be quite honest. So we'll pull that off, we'll unsolder the caps, and then we'll do some ESR testing. A little we'll try some of the different tests on here. I think it's got the dissipation factor, quality factor. We'll take a look at some of that in another video. But right now we'll finish disassembling this. Alright, so now we've got a good little heat sink here. Nice aluminum. Huh. I was hoping it was completely flat. It's got these two little indentations in them. Not really sure what for. Maybe airflow or something, I don't know. I wouldn't think so. So now we got to get this off of here, and then I may mount it right back on there for now. I may not. I don't know, but eventually we'll use this for a few different projects. So let's look at a few different magnetic pickups. This is a pretty common one people use, a little pull handle. It's kind of nice, it's kind of convenient to grab a screw in a tight area. You know, that's nice. But I tell you what, and this isn't really a magnetic pickup, it's just pretty cool. It's a magnetic switch. You turn it on and off. Right now you see it doesn't pick anything up. Turn that on, Ryan. And then there, it's pretty strong. It's extremely powerful. It's magnetic shunting, which maybe we'll do another video about that. It's pretty cool. Turn it off. So it's not an electric magnet, just permanent magnet. It just shunts the magnetic field inside. But I tell you what I use a lot of is just a little kid science toy, just a magnetic wand. I use this at work a lot for picking stuff up. And also if you're doing drilling, it's pretty good for catching filings, and you can wipe them off pretty clean. So it doesn't release as easily as this. So you may still want to pick up like that. Okay, I think I found the problem. This diode right here is blown. It's kind of hard to see. And it looks like these two diodes share a common trace that goes to the emitter right here. So I don't know if that's what caused it to fail or if that's a result of a failure. I guess it really doesn't matter. Let's look at this board though. These are power relays, and they're not accessible to replace in their PCB mounts, so they're not meant to be replaced. And even the auxiliaries, which come off, don't look like they're meant to be replaced. And I mean, you know how often auxiliaries go bad. So it's pretty shocking. I guess this is a 10-year drive or a 7-year drive, and you replace it. It looks like tested in, what is that, 2009? But I just can't imagine something like this lasting more than 10 years. But here's another interesting one. You know what? We will take this apart though, because you can see on these, if I'm looking at that, if I see what I think I see, the contacts are burned up. Because again, these are power relays. Okay, you've got two options, Ryan. To remove the solder, you could use this solder sucker. Go ahead and try that. Just a little vacuum, or you can use a wick. But if you get components too hot, you can damage them. So to start off with, I'm not going to have you do the IGBT or the caps. Let me let you start with something pretty easy like these inductors. So looking at this relay, Ryan, these contacts are a little bit crispy. It's hard to see. I need some better light, but yeah, they're a little crispy up in there. That's a better view right there. Okay, so we got these inductors, those caps. Get this last one right here, and then I'll let you try to do that. Okay, so now we need to get the IGBT off, unsolder it without damaging it, which we really don't know if it's already damaged. When that diode blew on that emitter, it may have took out the IGBT anyway. So start with these 4 screws. Let's get those out of there, and then we'll start working on desoldering it. Okay, when we looked at this sheet earlier, Ryan, I didn't notice that the pinouts are actually here. It's numbered. It's hard to read. We need to blow it up a little larger. But if you look, it starts at 1, 2, 3, 4, 5, 6. It just goes all the way around 7, 8, 9, 10 through 21, and then 22, 23, 24. And those all correlate right here. So with that information, you could test the IGBT right here before you unsolder it. So we may do that because I would like to know if it is good. We may damage it. We got to put a... It's hard to pry these off. Maybe there's a better way than what we're doing, but it's so many little solder joints that you end up having a hard time working it off, and then you end up putting a little bit more heat than you really should on the components. So I would like to know if that bad diode damaged this or what. Good eye, Ryan. I did not even see that. That little U9 chip is cracked. Huh. Check that out. I wonder, I wonder if this one got hit by lightning or something. That's 2 completely separate things. Maybe check the rest of it out. You might find something else. Okay, what we'll try to do is test all these freewheeling diodes right here. We can test this 3-phase bridge rectifier, those diodes, and we can also test that. And what we're going to do is we have 4, 5, and 6, and then the common side is 22 over here, and then 24 here. So we just find those here. We can see 4, 5, and 6, and then here they're a little obvious because it's got the thick traces right there. And then 22 and 24 are over here. 22, 24, so that would be here and here. So let's start. We'll put our negative on 22, and then our red will go to 4, 5, and 6, and we'll test the forward bias. So let's go ahead, put black on 22, which is right here. We're on diode test mode, and then we will go to 6. So that's a voltage drop. That's good. That reads good. Okay, now I'll swap them, and I should read OL. Good, good, good. So now we're going to move over here and test these, and I think we're going to see something wrong right there. We'll go ahead and put red on 24, which is, let's see, right here. And then we'll go black to 4, 5, and 6. So start on 6. We read a voltage drop, voltage drop, voltage drop. So everything looks good so far, but when we swap them, OL, OL, and then there we read something a little funny. So I believe that IGBT is probably bad, but it is in circuit, and there's possibility there's something in this circuit doing that, but I don't think so. I think it's bad, but we may completely destroy it desoldering it, so I wanted to test it first. Now we can go ahead and let's do that. We're going to test this as well, though. The 3-phase bridge rectifier is built into it, and it's also got that brake chopper circuit. We'll go here first, 7 to 22. So red on 7. Where is that? That's right here. And black on 22, which was over here. So voltage drop, and then we're just going to swap. Okay, so that diode's good. Now we'll check these 3 incoming. So let's go black on 21. where is that? Up here, according to this, 21 is right here. And then we're going to go red on 1, 2, and 3. So 1, 2, and 3. And then you can see pretty clearly that looks like the incoming. That's good. 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 We'll swap them. And good. 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 So we checked those 3, but now we have these 3 to check. So we checked the forward bias and then the reverse blocking. All right, so we'll do red on 23, which is, where is that? Right here. And then we'll do black on 1, 2, 3. Good. 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 Reverse it. Good. 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 Now we could also start checking to see if these are shorted, but we're not going to do that right now. I want to get this off of here. Well, as expected, it's hard to remove, and we'll probably looks like some of the pins are coming out. Well, we did destroy it pulling it off. Apparently these pins come out pretty easily, but it looks like this IGBT was already shot. So we read one bad diode, but I don't know about the other one. So what we'll do is we'll trace it out and see what goes where, what actually failed. But it seemed like the only one that we saw that read bad was that one right there. Seemed like all of these read good. I will double check it, because I expected we might do something like this in removing it, but I don't think we could have possibly done that. But you can see it even ruptured through the what I call the jelly. Well, there did not seem to be a whole lot in this drive. There's one IGBT, which we see it's got 2 failure spots in it, there and there. The drive caps are all pretty small. Didn't have very many of those. It really wasn't meant for servicing at all, or any kind of component replacement. Even the relays are soldered on there. Everything's pretty much soldered on there, meant to just be thrown away. So we got a few components off that we'll throw in some of the new testers and see how they compare. Let's see, what do we got? A few small inductors, obviously some large inductors, a few different caps, resistors, which I've got tons of those. Most of these are MOVs. None of these really test an MOV, but I was really hoping for a larger cap bank. I did get a nice heat sink out of it though, so that's good.